Welcome to Singapore Junior Physics Olympiad 2012 General Round Question 22. Two identical rectangular bricks of length S are piled with one on top of the other on the table. What is the maximum distance L? See the figure below. That the top brick can be extended beyond the edge of the table for the system to remain balanced. Note that the figure is not drawn to scale. The options are A, S/2, B, 2/3 of S, C, 3/4 of S, D, 7/8 of S, or E, S. Now to begin solving this question, we first look at the free body diagram of each individual blocks. We start with the top brick. So as usual, one of the force acting on this brick is due to the weight of the brick itself. Next, due to being in contact with the bottom brick, the top brick also experiences a normal reaction force. Now the position of the normal force should be in line with the position of the weight force to balance out the top acting on the brick due to the weight. So it's obvious from this free body diagram that the maximum distance the top brick can stretch off the edge of the bottom brick is actually S/2. This is because if you move just slightly beyond half of the brick, the weight of the brick is going to have a torque acting on this point of the surface. And you can see from this free body diagram that there's actually no compensating torque to act against the torque due to the weight of the brick. Therefore, the maximum distance is only S/2. Now let's look at the free body diagram of the bottom brick. So as usual, one of the force acting on the brick is the weight of the brick itself. Next, due to being in contact with the top brick, at the edge of the brick there's also a normal reactions acting on the brick as shown here. Now the fact that it's also contacting with the surface, the brick also faces a normal reaction of N prime from the surface. And the position of this normal reaction from a surface, for now we call it at the distance x from the edge of the brick. So from what you can see here, that the weight of the brick as well as the normal reaction due to the top brick has a resulting torque acting at this point of the brick. So in order for the brick to stay equilibrium, this torque must be equal to each other. So we can construct the equation as shown here. Now for the top brick to remain equilibrium, we also need the normal reaction to be equal to the weight of the brick itself. So substituting this condition into this equation, we can compute for x equals to S/4. Therefore, the length of L is actually equal to x plus S/2, which gives us an answer of L equals to 3/4S. Therefore, the answer to this question is C, 3/4S.